You know those sci-fi movies, right? The ones with the super sleek, intelligent robots that just glide through our world so easily? But then you see a real-life video of a robot trying to, pick up a coffee mug, and it's pretty clunky. There's this huge gap between the dream and the reality of robotics. So today, we're going to dive into a really fascinating new approach that might just close that gap by giving robots something they've never had before: an imagination.
For years, robots have been the undisputed champions of the assembly line. They're perfect at doing the same repetitive task over and over again in a super controlled environment. But here's the thing that's always puzzled me. Why are they still stuck there? Why aren't they in our homes or helping out in hospitals? Where they could really make a difference?
And it really all comes down to a problem that's super easy to relate to. Just ask yourself, why can't a state-of-the-art, super expensive robot clean up a messy kitchen? It feels like it should be able to, right? But the real world, it turns out, is just infinitely more complicated than a factory floor.
And this, right here, this gets to the absolute heart of the problem. On one side, you have the lab. It's this perfect little world. Everything's predictable, the lighting is just right, all the objects are known. On the other side, you've got reality. You've got your kitchen. It's messy, it's unpredictable, things are never where you left them. A robot that's trained for that perfect lab world is just completely, utterly lost in the chaos of the real one.
This is exactly why the old way of teaching robots just completely falls apart in the real world. First off, just collecting data from a physical robot is incredibly slow and super expensive, and there's just no way you can train it for every single spoon or cup or crumpled up napkin it's ever going to see. Plus, even the training it gets in one kitchen doesn't really help it understand a different one.
Okay, so if the old way is kind of a dead end, what's the alternative? This is where things get really, really cool. Researchers have come up with a totally revolutionary new approach, and it's all centered on giving robots a kind of imagination.
It's called DreamDojo, and the core idea is just brilliant. Instead of trying to teach a robot with that slow, expensive robot data, DreamDojo is an AI that learns how the physical world works by watching thousands of hours of videos of us, of humans, interacting with the world. It uses all that knowledge to build what you can only describe as a physics-aware imagination.
Think of it like this. DreamDojo gives the robot its own little internal mental simulator. So before the robot even touches an object, it can imagine what might happen if it pushes it, or picks it up, or maybe drops it. It can play out all these different scenarios in its head, kind of like we do. So, how in the world does this actually work? What is the secret sauce that lets an AI learn about physics just by watching a bunch of videos? Let's break it down.
So it all starts with an absolutely massive amount of data. And I mean a ton. We're talking over 44,000 hours of first-person video. This is just footage of people doing everyday stuff: cooking, cleaning, putting things together. This dataset is so incredibly rich, it shows thousands of different objects and actions, all in messy, real-world situations.
Okay, but here's the million-dollar question. All those 44,000 hours of video, they don't have any labels. There's nothing saying, this is a person picking up an apple, or this is someone opening a drawer. So how does the AI have any clue what's happening? Well, this is the really clever part.
The answer is a concept they call latent actions. So imagine the AI is looking at a video, frame by frame. It looks at frame 1, then it looks at frame 2, and it basically asks itself, okay, what happened in between? Did a hand reach out? Did an object get pushed? By analyzing millions and millions of these tiny what happened moments, it starts to build its own dictionary of actions. It actually creates a universal language that a robot can understand, and it does all of this without a single human label. It's amazing.
The whole thing really boils down to 3 main steps. First up, pre-training. The AI just binges all 44,000 hours of human video to get a general sense of, how the world works. Next is post-training. It takes all that general knowledge and fine-tunes it with a little bit of robot-specific data. That teaches it how to apply what it knows to its own robot body and its grippers. And finally, distillation. This takes that huge, complex AI model and shrinks it down, making it lean and fast enough to actually think in real time.
Now that all sounds great in theory, but you know what we're all thinking. Does it actually work? So let's get to the good stuff, the results, and see how this new approach really stacks up.
And wow, the results pretty much speak for themselves. When they tested its ability to predict physics in totally new situations, DreamDojo was a staggering 62 to 73% more accurate than the older models. That isn't just a little improvement. That is a massive leap forward in a robot's ability to understand cause and effect.
But honestly, this is the number that really blows me away.
The predictions made inside DreamDojo's little mental simulator, they had a 95% correlation with what actually happened in the real world. So that means what the robot imagines is an incredibly accurate reflection of reality. That's just wild.
So what does all this add up to? What's the bottom line? Well, when a robot uses this imagination to plan what it's going to do, its success rate doubles. It literally doubles. I mean, this isn't just a small step forward. It's a total game changer for what robots are capable of.
Okay, so clearly this is a huge technical achievement. But let's zoom out for a second and talk about why this actually matters for all of us. Because this isn't just about making robots a little smarter. This could be unlocking a whole new era for robotics.
And this isn't some far-off future thing. The practical applications are already here. Developers can now test new robot behaviors in a perfectly safe virtual world without ever risking breaking expensive hardware. That just dramatically speeds up how fast they can develop new skills. It means the path to robots that can actually help with elder care, or perform delicate tasks in a lab, or heck, just unload your dishwasher. That path gets a lot shorter and a whole lot cheaper.
In the end, it all comes back to this one really powerful idea. It's about fundamentally changing how robots learn by giving them a physics-aware imagination that's built from the massive wealth of all our human experience.
You know, this system was trained on 44,000 hours of video, which is a lot. But it leaves us with one last really provocative question to think about. What happens when a system like this can learn from every relevant video on the entire internet? What kind of world is that going to enable?